Hello, everybody, and welcome to the SDB Monthly Updates, where we share updates and announcements from the product team. My name is Neha Paki, and I am the head of product here at Datacebo. And today, I'll be going through some updates for April 2026. So for the past few months, our focus has been on reducing the manual work required when you're building generative models. Automated techniques are required for scaling to larger, more complex relational databases, especially at an enterprise level. And so that's why this month, we're excited to roll out a major feature related to automation. Auto-detecting constraints. In SDV, constraints are an important feature that ensures the synthetic data is fully valid for relational datasets. So let's take a look at what this means and where constraints really fit in when creating synthetic data. So to see where constraints fit in, we can look at three important requirements that make synthetic data correct. The first is the statistical quality that describes how similar the synthetic data is to the real data. This is where we look at measures like the distribution of values in a column or the correlation. Statistical quality is probabilistic, meaning that it's about a general trend. And generative AI models, like the ones used in SDV, are designed to learn and optimize learning these probabilistic trends. Then in the middle, we have the database structure. So SDV is designed to model relational databases. We built it from the ground up to understand all these concepts that a relational database has, like primary keys, referential integrity, composite keys, and more. And then finally at the right, we have the rules of validity. And these are business rules or logic that must be followed in order to create valid data. And this third area is really where constraints are designed to work. So what exactly is a rule of validity? Well, here's a simple example of hotel guests checking into and out of hotels. The rule of validity here is that the check-in date for a guest must always occur before their checkout date. No exceptions. And this isn't a probabilistic trend, right? It's a rule that needs 100% accuracy. And if synthetic data doesn't adhere to that rule, it's not valid, and a downstream application may not be able to use it. And so that's why it's especially important to adhere to these rules for enterprise datasets. We realized pretty early on that rules across different datasets usually have a similar structure and follow similar logic. And so we encapsulated that logic into predefined constraint classes. You can think of them as templates. So you pick out a template and then you fill in more details about where exactly that logic appears in your specific database. So the example at the left, right? In the hospitality industry, there's that rule that a guest must check in before they check out. But in the financial services industry at the right, there's a similar rule that an account must be created before a loan can be issued to it. So both of these types of logic can be described by the predefined inequality class. So in either case, you'd fill out the template for this inequality class by specifying the column that should be earlier and the column that should occur later. And so once you specify this, SDV then uses something called constraint augmented generation, or CAG, that guarantees that the synthetic data meets the rule 100% of the time. So inequality is just one of these classes. In SDV, we have predefined classes for 16 constraints and counting. And they encompass logic that is varied across different datasets. So some of this logic occurs within a single table, which is what we call single table constraints. And some logic actually describes what happens between different tables of a relational database. And that's what we call multi-table constraints. And so you can browse all these different constraints in our docs. I'll leave a link in the video description. Constraints are great, but a lot of our customers have given us feedback that they don't know all the rules of validity in their dataset, right? So they don't know which constraints really to add. And this is part of a broader problem of data lineage. So the database schemas that enterprises are typically working with are the result of many decisions made over several years. And as this complexity keeps increasing, it just becomes harder and harder to track all the rules and assumptions that are part of the database setup. So essentially, generative modeling for these relational databases will not scale if you have to identify and specify and add all these constraints manually. The answer to this is automation. And that's why we're excited to introduce constraint auto-detection algorithms. Constraint auto-detection allows SDV to automatically find all the rules in your dataset and then add them to the modeling engine as constraints. So there's no more manual work that's required for you to identify them. So in the code box, I'm showing what the algorithms can find. So auto-detecting constraints here means that the algorithms are automatically finding those templates, those constraint classes that are relevant to your dataset, and it's filling them in with your specific tables and columns. The response to this feature has been overwhelming. This feature is taking generative modeling, especially for relational databases, to a whole new level. So it's automatically detecting data lineage, it's reducing the manual work that you need to identify the constraints, and at a higher level, it's even providing a new level of data understanding. And so now all these different aspects of synthetic data correctness are automated. The statistical quality, database structure, and now the rules of validity. In an enterprise setting, we find that almost all relational databases have constraints. We tested out our auto-detecting capabilities across many different public datasets, especially the ones that were published by large organizations. So an example here in the healthcare space is Cynthia. They published a dataset with 18 tables that contained many different concepts like patients and payers and medications and more. And then Microsoft has a dataset called AdventureWorks that they've published as a showcase for their database capabilities. So generally across all these datasets, there are a few common constraints that we frequently found. So the first is fixed combinations, which indicates which columns kind of belong together, like city and state. Then there's inequality, which we've already seen in the hotel example, where check-in date must be less than check-out date. And then third, there's carryover columns. So this occurs when the data is stored redundantly across different tables, usually for query optimization. And so there's this rule that the data must be synchronized across all these different tables in a relational database. So these are just a few examples. Some data sets here had over 50 constraints, and the different constraint classes actually work together to ensure that the full relational database is valid when you create that synthetic data. So complex constraints and the auto-detection of those constraints has been rolled out to our customers. All the features are available in the CAG Bundle, which is an add-on to SDB Enterprise. And now I want to quickly go through one additional item that's on the roadmap, and it's also related to more automation. So I'm excited to announce that we are working on improving the synthetic data that we generate for ID columns, like primary keys. So there's kind of two aspects to this. The first is that we're auto-detecting the regex format that the ID value should have. So for example, 2 letters, then a few numbers, and then some letters again. The second is that we're also building the ability to extract and learn context that's embedded within the ID column. So in this example, the ID represents a flight. And the first 2 digits here are not random. They actually correspond to the airline, like DL for Delta. And then the next few numbers are also not random, they correspond to the route. So our enhanced ID generation will allow you to see more realistic ID values when you create the synthetic data. And similar to constraints, this might be important for your downstream applications, for example, if they need to parse out some of this context down the line. And with that, I want to thank you all for tuning into the April update. You can visit docs.sdb.dev to learn a little more about the CAG bundle and browse the different constraint classes. I'll see you next time for the May update.